All right, so example 2, we're going to prove that we have an isosceles triangle. And take a look at this. We've got so many things filled in for us. So this one's kind of nice, but we do want to make sure that we understand every step of the way. Even though we maybe don't have to come up with the reasons on our own for this example, we want to make sure we understand it so that we can come up with it on our own moving forward. All right, so let's start with the given. BC is perpendicular, that's your symbol for perpendicular, to AD. So here's BC perpendicular to AD. Well, perpendicular means that you have two right angles. So that's what perpendicular lines give you. All right, we're also given that C is the midpoint, so C is the midpoint of AD. Well, a midpoint takes a segment and cuts it in half, so we know that we have two congruent segments right there. All right, so in order for us, let's think ahead. In order for us to say that this is an isosceles triangle, you want to prove that you have two, that your legs of this bigger triangle are congruent. So we want AB and DB to be congruent to each other. Now, those are corresponding parts of these two smaller triangles. So we're going to go ahead and prove the two smaller triangles as congruent so that we can say that those two legs are congruent. All right, so let's start with our proof. BC is perpendicular to AD. That's given. Now we've got two statements to make, and you can see it says definition of perpendicular. So what we're going to do there is we're going to state, we drew them in. You can see we drew in these little right angle notations. So we want to go ahead and state that those are right angles. So angle BCA is a right angle. How did we know that? Because of our definition of perpendicular. Let's go ahead and say that the other angle, angle BCD, is also a right angle. So this covers the two right angles that we have. And again, that is definition of perpendicular. Well, if you have two angles that we're stating are right angles, we can go ahead and say that they are congruent to each other because of our right angle theorem. Just to say that they're both right angles doesn't mean that they are congruent. It seems kind of like, well, obviously they're congruent, but we still have to write it down and state it in our proof. So now, because we've classified them both as right angles, we can say that angle BCA is congruent to angle BCD. And that's our right angle theorem. All right, now we're going to work with this midpoint information that was given to us. C is the midpoint of AD. That's given. Well, that gave us our two congruent sides. So next, we're going to say that those two sides are congruent. AC is congruent to DC. And we knew that they would be congruent because that's our definition of midpoint. That's what it means. All right. So far in our two smaller triangles, we have a side, pair of sides that are congruent, and we have congruent angles. So we need one more thing. Remember, you need side, 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 or side, angle, side, or angle, side, angle. You need three things to be congruent. So the next thing, hopefully you already came up with it, but if you're unsure as we're working through this the first time, you can see we're going to use the reflexive property next. So what are these two smaller triangles sharing? They're sharing this middle side right there. So BC is congruent to BC. And those are your, that's the reflexive property that gives us those congruent sides. Okay, so do we have enough information to say that our triangles are congruent? We have a side, an angle, and a side. And that's an included angle, so that is a side angle side congruency. So yep, we can say the triangles are congruent. Triangle ABC is congruent to triangle DBC. And that's side angle side. Now once you have congruent triangles, you can say that anything is congruent within the triangle. Well, this is what we want. We want these outside sides to be congruent because those are the legs of our isosceles triangle. So now we can go ahead and state that AB is congruent to DB, and that's our CPCTC. Corresponding parts of congruent triangles are congruent. And now that we have these, I'll go ahead and mark it, these legs as congruent, we have enough information to say that triangle ABD, the bigger triangle, is an isosceles triangle. And how did we know that it would be? Because of our definition of isosceles triangle. Are you guys having fun with these proofs yet? They're not too bad, right?